Okay, this is the second video for section 7.4, finding area and arc length in polar coordinates. The polar coordinate system I have here is from the OpenStax Calculus Volume 2 textbook from page 465 or 645, I can't remember, one of those two. It's in section 7.3, I believe. And what we want to do here is we want to find the area inside the loop of lemicon r equals 10 minus 20 sine of theta. So we're going to go ahead and we have 10 minus 20 sine of theta. We're going to use the standard 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we'll complete our table. So sine of 0 is 0, so we just have 10. Sine of pi over 2 is 1, so we have 10 minus 20, which is negative 1. Sine of pi is 0, so we just have 10. Sine of 3 pi over 2 is negative 1, so we have 10 minus 20 times negative 1, so that becomes 10 plus 20, which is 30. And sine of 2 pi is 0, so we just have 10. Okay, so 10, 20, 30. Negative 10 is the lowest here. And let's go ahead and start graphing. So we'll label our rings 10, 20, and 30. Okay, and at 0 we're all on the first ring at 10. Okay, and then at pi over 2 we drop down to a negative 10. So instead of going in the pi over 2's direction, because of the negative 10 there, we're going to go in the opposite direction, so down towards 3 pi over 2. And so we cross the x-axis at some point in time, so let's figure out where we cross the x-axis. So that would be where 10 minus 20 sine of theta is equal to 0. So we'll subtract 10 and divide by negative 20, and we'll have the sine of theta is equal to 1/2. That occurs when the theta is equal to pi over 6 or 5 pi over 6. Okay? Alright, so at pi over 6 is where we cross the x-axis, so I'm going to try to draw it in there. Okay, so there it is. And then we're going to come back up, and at pi we're at 10. And we cross the x-axis again at 5 pi over 6. We're going to go through the pole at 5 pi over 6. Okay, so that gives us the next part, and now you see your loop there. Let's finish off our graph. So at 2 pi... at 3 pi we're all the way down to 30. And then at 2 pi we're back at 10. And so there we go with our lemicon. Okay, and we want to find the area of the loop, which is going to go from pi over 6 to 5 pi over 6. Okay, so the area is going to be 1/2 integral from pi over 6 to 5 pi over 6 of 10 minus 20 sine of theta squared d theta. So it's going to be 1/2 integral from pi over 6 to 5 pi over 6 of 100 minus 400 sine of theta plus 400 sine squared of theta d theta. Okay, equals, and everybody's got a factor of 100, so we'll factor out a 100, so we have 100 over 2, integral from pi over 6 to 5 pi over 6, 1 minus 4 sine of theta plus 4 sine squared of theta d theta. Power reducing formula, sine squared of theta is equal to 1 times 1 minus the cosine of 2 theta. So we have 50 equals the integral from pi over 6 to 5 pi over 6 of 1 minus 4 sine of theta plus 4 times 1/2 1 minus the cosine of 2 theta d theta. Okay, and we're about out of real estate here, so we're going to go on to the next slide. So we got the same integral right there. We'll go ahead and simplify it. So this is going to be 50 integral from pi over 6 to 5 pi over 6. I don't know where pi over 2 came from. Sorry. And where did the 3 come from? Well, you got 1 here, and then you got the 2 times the 1 over here. It's going to be 2 times 1, and then minus 4 cosine of not 4, it'd be 2 cosine of 2 theta there. Okay. So 3 minus 4 sine of theta minus 2 cosine of 2 theta d theta. That's going to be equal to 50. And then we'll go ahead and integrate 3 theta plus 4 cosine of theta minus 2 sine of 2 theta all over 2. And then we're going to evaluate that from pi over 6 to 5 pi over 6. So that's 50. And then 3 times 5 pi over 6 plus 4 cosine of 5 pi over 6 minus sine of 2 times 5 pi over 6 minus 3 times pi over 6 plus 4 cosine of pi over 6 minus the sine of 2 times pi over 6, which is equal to 50, and we have 5 pi over 2 plus 4 times negative root 3 over 2 minus negative root 3 over 2 minus pi over 2 minus 4 times root 3 over 2 and minus 3 over root, it'll become plus because of the double negatives there, so plus root 3 over 2. It's going to be 50, and we got pi over 2, okay, and then we got, let's see, a negative 4, a positive 1, a negative 4, and a positive 1 in terms of like terms. So negative 4, positive 1, negative 4, positive 1, so it's going to make it a negative 6 root 3 over 2. So it's going to give us 50 times 2 pi minus 3 root 3, and that is approximately, I think it's 54 point something something. I can check for you. Yeah, about 54.3516 if you wanted a decimal value there. Alrighty, I got one more for you on this video, and we are going to find the area bounded by r squared equals 7 cosine of 2 theta. And this is going to be a lemniscate. We're going to take the 72, we're going to write it as 36 times 2 because we're going to take the square root to solve for the r. So we're going to have r equals, and square root of 36 is 6, and then we don't know what the square root of 2 is, so 6 square roots of 2, and then the square root of 2, and then the square root of cosine of 2 theta. Okay, our lemniscate. And we want to line things up nicely, so we're going to have 2 theta equal 0, pi over 2, pi, 3 pi over 2, and 2 pi. So then theta is equal to 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay. And the maximum is 6 root 2, and we're not going to have any of the negative values because we're going to be taking the square root. So so we're going to just use the fourth ring to be our 6 root 2. Okay, so at 0, we're going to have the point 6 root 2 or 6 root 2 comma 0 right there. Okay, and then at pi over 4, we're going to be at 0. By symmetry, we're going to back this up and we're going to go to negative pi over 4, and so we get part of our lemniscate, so half of it right there. So there it is. Okay, and I put in the radial lines pi over 4 and negative pi over 4 to kind of help with the sketch. Okay, all right, then we have no man's land from pi over 4 to 3 pi over 4. Okay, and then 3 pi over 4 is going to be another 0. Okay, and then we increase by pi over 4 to get to pi. And that'll give us a maximum of 6 root 2. Pi plus pi over 4 will be 5 pi over 4. And that'll give us our other, I guess, kind of our pedal for our lemniscate. Okay, and so put in your radial lines of 3 pi over 4 and 5 pi over 4, which looks like we missed the divide by 4 there. Okay, so there it is. Now we're looking at finding the area of this. It is symmetric, so we only need to find the area of one of them and then go ahead and double that. So let's go ahead and find the one from negative pi over 4 to pi over 4, and we're going to go ahead and then double that. So there's the 2 times, and then it's 1/2 integral from alpha to beta, so negative pi over 4 to pi over 4. And then r squared, which is conveniently 72 cosine of 2 theta, so that's already there for us. D theta. Okay, so that's going to be 72, and that's going to be the sine of 2 theta over 2, evaluated from negative pi over 4 to pi over 4, which is going to be equal to 36, the sine of 2 times pi over 4, minus the sine of 2 times negative pi over 4. So that's going to be 36, and that's going to be the sine of pi over 2, which is 1, minus the sine of negative pi over 2, which is negative 1. So we have 36 times the quantity 1 minus negative 1, or 36 times 2, and that's going to be 72. Okay, alrighty, I got one more video for you, and we're going to be looking at finding the arc length. So we'll see you in the next video.